Hello, everyone. Today, I would like to discuss how to build a more robust Apache APISIX Ingress controller with Litmus skills. Let me introduce myself first. I'm Jintao, an Apache APISIX PMC member, maintainer of the Kubernetes Ingress NGX project, and Microsoft MVP. If you would like to get in touch with me, you can find my GitHub profile and email address on the slides. In this talk, the agenda is to discuss why we need chaos engineering, how to design chaos experiments for an ingress controller, how to practice it, the benefits and the future of this field. First, why we need chaos engineering? Let's review the definition of chaos engineering. Chaos engineering is a process of evaluating software systems by simulation destructive events such as server network outage or API throttling. In this process, we test the system's resilience and reliability in unstable and unexpected conditions by introducing chaos. For example, server faults. Chaos engineering can also help teams simulate real-world scenarios in a security control environment to uncover hidden risks and identify performance bottlenecks in distributed systems. This approach is an effective way to prevent system downtime or production interruptions. Netflix's approach to handling systems inspired us to take a more scientific approach that's driven the birth and development of the chaos engineering. What is chaos engineering? I think the first one is the introduction of the disruptive events. Chaos engineering involves introducing disruptive events such as network partitions, service degradation, and resource constraints to simulate real-world scenarios and test the system's ability to handle unexpected conditions. The purpose of this is to identify and weakness and use the information to improve the system's design and the architecture, make it more robust and resilient. Then test the system's resilience. Today the technical landscape is constantly involved and fast-paced. To ensure the systems are robust, scalable, and able to handle unexpected challenges and conditions, it's very important to test the system's resilience in real-world scenarios. Chaos engineering is an effective way to do this. It involves introducing disruptive events to observe the system's response and measure the ability to handle unexpected conditions. To measure the impact of the disruptive event on the system resilience, organization can monitor system logs, performance metrics, and user experience. By tracking these metrics, organizations can gain a better understanding of the system's behavior and identify area of the improvement. Next one is discovering hidden problems. Distributed system can be prone to hidden issues such as data loss, performance bottlenecks, and communication errors. These problems can be hard to detect as they often only become visible when the system is under pressure. Chaos engineering can help uncover this hidden issue by introducing disruptive events. This information can then be used to improve the system's design and architecture, making it more reliable. By identifying and resolve this problem, organization can enhance the reliability and performance of their system. This can help prevent downtime, reduce the risk of data loss, and ensure the system continue to run smoothly. What is worth and why we need it? Then, why we need it? First, distributed systems are complex and with many inherent chaos in the system. The use of cloud and microservice architecture provide us with many advantages, but it also comes up with complexity and chaos, which can lead to failure. The engineer's responsibility is to make the system as reliable as possible. Without testing, we have no confidence to let our project be used in production environment. In order to make it more robust, in addition to the conventional unit test, end-to-end test, we decide to introduce chaos test. When an error occurred, repairing it takes time and can cause immeasurable loss, which may have long-term effect in the future. In the process of the repair, we need to consider various facts, include the complexity of the system, the type of the error, and possible new problem in order to ensure that the final repair is effective. Moreover, when an open source project brings serious faults to the user in the production environment, many users will choose to switch other products. Back to today's topic, how to design chaos experiments for an ingress controller. Let's talk about what is Ingress first. Ingress is a resource object in Kubernetes. It contains rules for how clients outside the cluster can access the service inside the cluster. These rules include which client can access which service, how to route client requests to the service, and how to handle client requests. On the right is a simple example. As you can see, Ingress is a very simple resource. No need to make it more complicated than it needs to be. Then, what is Ingress controller? An ingress resource requires an ingress controller to process it. Otherwise, it has no practical use. The ingress controller translates the ingress rules into configuration on a proxy, allow external clients to access service within the cluster. An ingress controller is a specific type of load balance that receives ingress rules from the cluster and then translates them to configuration that can proxy client rules. This effectively manages how external clients access service with the cluster. However, in a production environment, we need more complex capabilities such as limiting access source and request method, authentication and authorization. The ingress resource object doesn't include this part, so most ingress controller extend the semantics of the ingress through annotations in the ingress resource. Different ingress controllers have different implementations. For example, the annotation used by Kubernetes Ingress NGX and Apache APISIX Ingress are different. Okay, what is Apache APISIX Ingress? Apache APISIX Ingress controller is a controller for Kubernetes Ingress resource that helps administrators manage and control ingress traffic. It uses Apache APISIX as a data plane to provide users with dynamic routing, load balance, and security policies and other features to improve network control and ensure high availability and security for their business. APISIX Ingress supports 3 configuration methods. You can use Kubernetes Ingress and customer resource or gateway API. Each of these has its own advantage. For example, if you're using ingress resource, this is simple to describe and is a resource carried by Kubernetes by default. It's also easy to integrate with other components. Next one is the Gateway API. Gateway API is the next generation ingress, provide rich semantics and functions. Also, the last one is CRD. Apache APISIX Ingress provide a set of customer resources to APISIX's own resource, which is convenient for user to use and understand. APISIX Ingress adopt a special architecture with the control plane handling routing rules without carrying business traffic. All client requests are processed through the data plane. Therefore, any abnormality in the control plane will not affect the traffic. In addition, APISIX Ingress controller has a retry module. After the control plane component is restored, the routing rules can be synced to the data plane. And APISIX Ingress also support integration with external service discovery components. Then, what is Litmus Chaos? Litmus Chaos is an open source chaos engineering framework and incubating project of the CNCF. It provides an infrastructure experimental framework to validate the stability of controllers and microservice architecture. It can simulate container level and application level environment as well as nature disasters force and upgrade to understand how the system responds to these changes. The framework can also explore the behavior changes between controller and applications and how controller responds to challenges in specific status. In addition, Litmus Chaos offer convenient observability integration capabilities. It is high extensible and integratable with other tools to enable the creation of customer experiments. Kubernetes developers and SREs use Litmus to manage chaos in a declarative manner and identify weaknesses in their applications and infrastructures. Someone asked me why I choose Litmus Chaos over other products. That is a topic for another time, but for summarize, Litmus Chaos has future functions I need, and I'm more familiar with it. Okay, how to design chaos experiment? This is a general procedure application to applicable to the design of the chaos experiments in any scenarios. First, you should define the system and the test. Identify the specific components of the system you want to experiment on, and develop a clear and measure objective for the experiment. This includes creating a comprehensive list of the components, such as hardware and software, that will be tested, as well as defining the scope of the experiment and the expected outcomes. Next one, choose the right experiment. Select an experiment that is aligned with the objective you have set, and closely mimics a real-world scenario. This will help ensure that the experiment product meaningful result and accurately reflect the behavior of the system. Next one is establish a hypothesis. Establish a hypothesis about how the system will behave during the experiment and what outcome you want. This should be based on the past experiments experience or research, and it should be reasonable and testable. Next one is run the experiment. Run the experiment in a controlled environment, such as staging environment, to limit the potential for harm to the production system. Collect all relevant data during the experiment and store it securely. There may be different opinions on whether the experiment should take place directly in the production environment. However, for most scenarios, we need to ensure the service level objective of the system is met. The last one is evaluate the result. Evaluate the result of the experiment and compare them to your hypothesis. Analyze the data collected and document any observation or finding. This includes identify any unexpected result or discrepancies and determine how they might affect the system. Additionally, consider how the result of the experiment can be used to improve the system. Okay, let's see the main usage scenarios of the Ingress controller. Proxy traffic is the most important capability, so I write it 3 times. The other functions are all based on the core functions. Consequently, when conducting chaos engineering, normally proxy traffic is the key metrics. Next, we can use the general mode above to define the system under the test. We can see for APISIX Ingress, users need to create root configurations such as Ingress Gateway API or CRD, and apply them to the Kubernetes cluster through kubectl. This process goes through kubeAPI server for authentication, authorization, and then store it in etcd. Then APISIX Ingress controller continually watch of change in the Kubernetes resources. These configurations are then translated to the configuration on the data plane. When a client requests the data plane, it accesses the upstream service according to the routing rules. It is clear that if kubeAPI server has an exception, it will prevent the configuration from being created or the Ingress controller from getting the correct configuration. This is an obvious and certain scenarios, so no experimentation is needed. If there is an exception in the data plane, such as network interruption, crash, or port killed, it will also not be able to do normal traffic process, proxy. This is also doesn't need to experiment. Therefore, the scope of our experiment is mainly the impact on the system availability if the Ingress controller has an exception. Next, we can choose the right. We should choose the right experiment. Based on the above reasons, we can directly cover many scenarios of incorrect configuration through end-to-end test, mainly through chaos engineering to verify whether the data plane can still proxy traffic normally. When the ingress controller occurred an exception, such as DNS error, network interruption, or port killed, then establish a hypothesis for each sequence. We can create the following hypothesis. When the ingress controller get something, the client's request can still get a normal response. This is our hypothesis. Next, we should run the experiment. The experiment and variable has been determined, so all that is left is to conduct the experiment. Litmus chaos provide various ways to conduct an experiment. We can do this through the Litmus portal. To do this, we need to create chaos scenarios, select the application to be experimented on, and these steps are relatively straightforward. However, we must pay attention to the factor that Litmus chaos include a probes resource. The problem resource are pluggable checks that can be defined with the chaos engine for any chaos experiment. The experiment pods execute these checks based on the mode they are defined in, and factor their success as a necessary condition in determining the victory of the experiment. In addition to the standard in-building checks, at the same time, we can also schedule experiment, which is a very variable function. Additionally, Litmus also support running experiments by submit YAML manifest. Then, how to evaluate the resource? Litmus has built-in statistical repos that clearly show the result of the experiment. There are also other rich reports, such as the comparison of experiment tensions, execution records. It can also be injected with Prometheus and Grafana to provide a unified dashboard for integration. However, due to my current experimental scenarios, I only used the built-in reports. Then, the benefits and the future. Apache APISIX is an open source project that is applied to various company and environment. Chaos engineering has given us confidence that the delivered APISIX Ingress is stable and reliable. Thanks to our complete end-to-end test, we no longer need to worry about unexpected behavior due to the introduction of new PRs. Chaos engineering has also helped us to identify a bug. When multiple consecutive kills of the APISIX Ingress controller pod occurred, it may cause a configuration failure. Cause a configuration failure. Fortunately, this problem has been fixed, and I'm now conducted continual chaos test through a private deployment environment. I plan to introduce chaos experiments based on Litmus into the CI environment of Apache APISIX Ingress project. And I want to provide reference documents and examples for other open source users to implement chaos engineering on APISIX Ingress in their own environment. That's all. Thank you. I'm honored to be here to share some of my experience with you. If you are interested, feel free to contact me anytime. See you.